Hello everyone. So today we're solving a system of differential equations. X prime is equal to matrix 2, 0, 1, 2, 1, 2, minus 2, 0, minus 1x plus e to the t, e to the minus 4t, e to the 5t. And yeah, we're going to be using variation of parameters here. So we're given x prime ax plus g of t. So it's a non-homogeneous equation basically here. We have that x bar equals phi of t times u of t, where phi of t is a fundamental matrix, which basically includes the eigenvectors and eigenvalues of the homogeneous solution here. So let me put that in of homogeneous. And yeah, u of t is made up in this case of a column vector, 3 rows, 1 column, u1t, u2t, u3t. And what we're going to be looking primarily here is that phi of t times u prime of t equals g of t. So for the matrix A, we have 2, 0, 1, 2, 1, 2, minus 2, 0, 1 was given. And we calculate the eigenvalues and eigenvectors of each of those right there. All the eigenvalues and eigenvectors that we need. And we're going to go ahead and form a fundamental matrix by taking each of the eigenvectors and multiplying by e raised to each of those eigenvalues. So starting with 1 minus a half minus 1, 1 times e to the 0, then 0, 1, 0 times e to the t, and then minus 1, 0, 1 times e to the t. And this is what you'd come up with right here. Let me just go to that right there. And you would have phi of t times u prime equals g of t would be your next move. You take your fundamental matrix, times it by u prime, which u prime will consist of u1 prime, u2 prime, u3 prime, equal to g of t. G of t is basically your non-constant vector on the other side. And you're going to solve for u1 prime, u2 prime, and then u3 prime. Now, how you choose to do this, it's up to you. I'm using Cramer's rule. And if you recall, Cramer's rule talked about finding determinants and dividing them. So for the way this works is that you take your determinant of phi of t, put it that way, and that comes out to be 1/2 e to the 2t down here. And on the top, you're going to have some determinants. These determinants are all different for u1 prime, u2 prime, and u3 prime. And the way it works is that you're going to take the determinant of phi of t and replace each column one at a time, though, by g of t. So when you're working with u1, you're going to replace the first column that you would have originally up here with g of t, those values. And then you would calculate that out. And that came out all the way up to here. So we did a bunch of math, simplified. I'm not going to calculate the determinant. But then you integrate to get u1. And then we're going to go ahead and calculate u2 prime as well. And the same manner, basically, I'm going to divide by the determinant of phi. And I'm going to replace the second column by e to the 3t, e to the minus 4t, e to the 5t. And we get our result. Again, you have to expand by minors and such. We integrate, and that's how we get u2. And then finally, for u3 of t, pretty much do the same thing. And yeah, we go ahead and get this right here. And your final solution is phi of t times u of t. And if you want to multiply this out, and obviously you're more than welcome to do this, and it works out somewhat nicely here. Okay, so that's how you deal with a 3x3 system. Okay, now as I said again, you can solve the system of equations here that we had as how you'd like. I used Cramer's method. You could have row reduced or done elimination, like an elimination method. It's up to you. However, I've primarily seen that most people feel comfortable with Cramer's method, so that's what I use here, Cramer's rule. There are other methods here to solve these types of equations. You also could use variation of, undetermined coefficients, which is a little bit lengthier and it deals with matrices and so just be aware that you have other options here. Okay, well, I hope this helps. Thank you for your time.